Alright, in this lesson we're going to do the same thing we've done many times before, and that's calculate a regression equation. But this time, rather than it being an exponential equation or a cubic equation or quadratic or even linear, it's going to be a logarithmic equation. Okay, and the way it shows up in your calculator is this form. And we haven't really talked about this yet. We looked at what the b did. The b, remember, if you had a value of b, the graph ended up going something like this as you increased the value of b. Well, the value of a we haven't talked about yet. That's basically going to move the graph up and down the y scale. So, for example, if this was, say, our natural log, if we would add 3 to it, the whole graph might actually move up like this. And this space here would be 3. So you would have ln x plus 3. Okay, and now you don't really need to worry about what that looks like on a graph because it's going to graph it for you on the calculator. So when you want to do the regression, now on my screen here I say it's 0. Well, in my calculator, 0 is actually the exponential equation. So make sure you pick the right one. Notice right above it is linear regression. Don't pick this one. We're picking the natural log. We don't have a log regression. We just have the natural log. Okay, and you're going to see this. You don't need to worry about r. R is what we call a coefficient, sort of like a coefficient of accuracy. You don't need to know that. We're not going to use that. Okay, so let's try a question. So it's a word problem, and it gives us a table. Sometimes you'll get the table, sometimes you won't. And the funny thing is here, before I even read this, just look at this table. Normally when we see a table, we see time here, and we see, like, in this case, percent change here. And if we did this, this would end up giving us an exponential equation. So all we've done for this logarithmic equation is we've switched x and y, so now it turns into a logarithmic equation. And this is one of the reasons why I'm hesitant to teach you too much about logs, because for the questions you're getting, you don't really need logs. We could switch these two and call this one x and this one y, and we could do it that way. But let's leave it. Let's just do what we're told to do here, and we'll do a log regression equation. Okay, so it says the flash in most digital cameras requires a charge capacitor in order to operate. The percent charge remaining on a capacitor was recorded at different times t after the flash had gone off. So, for example, if the flash hasn't gone off yet, you're going to have 100% charge, and every time you flash, you're going to have less charge left. Okay, so the T5 flash duration represents the time unit a capacitor is only 50% of its initial charge. The T5 flash duration also represents the length of time that the flash is effective, so ensure that the object being photographed is properly lit. Okay, here's another reason why I don't really like these log questions is, I don't know about you, but that doesn't make sense to me what I just read there. It's hard to do a word problem and understand the context and try to force it into a log equation. Whereas some of the other ones, like exponential growth, population growing, makes sense to me. It's easy to see that. I understand how it's doubling or whatever else it might be doing. This is difficult to understand. But we can do it. We can do what's asked. Construct a scatter plot. So let's go into our calculator, and we'll go to Stat, Edit, and we need to put this information in here. Okay, I think our first, let me just clear this first. Our first number was 100, and then our second one is, let me move this over here. So the second one then is 90.26, and then 73.90, 60.51, 49.54, and 40.56. Okay, and then here we're going to have 0, 0.01, 0.03, 0.05, 0.07, 0.09. Okay, so we've got the scatter plot. I can go zoom 9 to, oh, guess what I forgot to do? First of all, I forgot to get rid of this. Second of all, I forgot to turn the plot on. So there it is. Okay. Let's go look at the question now. So it says construct a scatter plot for the given data. So we could draw this very quickly. By the way, we saw those dots. How would I know how to label them? For example, what would this first dot be? Well, right from the chart, I know this means when x is 100, wait a second. Okay, so again, where is this first piece of data? Remember, this is the point 100, 0. Looking at our graph, where is 100, 0? Well, you can see that it should be somewhere around here. This is 100, 0. Then the next point is at 90.26. You have 0.01. And that's kind of weird. It's like we're putting these points in backwards. Okay? So it looks something like that. Let's see if we can now do the regression equation. Okay, so well, how do I do that? I go to Stat, Calc, and now I need to find that ln. So for mine it's 9. You'll have to see what it is for yours. Okay, I'm going to go at second L1, comma, second L2, enter. Okay, interestingly, I don't have the r and the r squared. Your calculator might. Again, you don't need to worry about that. So let's write what this is. Okay, this is y equals A is 0.4597 plus ln, oops, I forgot to put the b value, plus negative 0.0998 ln x. That's the regression equation. Let's go and paste that. Okay, there is the graph. Okay, it's a log graph, and so we'll see it looks something like that. Bit of an ugly one. Let's just make these dots a little bit bigger so it fits a bit better. Okay, and we know this is not going across the y-axis, and this keeps going down. Okay, what else does it ask us? Determine the logarithmic model. Did that. Use your logarithmic model to determine the T5 flash duration to the nearest hundredth of a second. Okay, before I answer that, part C, I actually just wanted to go back to this graph, look a little bit more closely at this. We didn't label this graph. We should label this. So what's our y-axis? Well, if you look on the table, our y-axis is time. So I should write that here. That's in seconds. And then here, this is our percent charge. Okay, And there's a couple other things I want you to notice. This is a log graph, right? And a log graph looks like this. But for this graph, it actually would probably stop here. Why would it stop there? Why would it not go down here? Well, time is our axis, and time can't go negative. Okay, we wouldn't have a negative value here, and in fact that would mean that it would be more than 100% charged. That doesn't make sense for this data down here. Okay, and I've put 100, 0 here because I know that's a point I plotted. It's actually, if you look on the graph, it's actually 99.9 on the regression equation, because the equation is trying to match the points as closely as possible. Okay? But that's good like that. I think our graph looks pretty good. So now let's do part C. It says, use your log model to determine the T5 flash duration. The T5 flash duration, so that's up here, represents the time until a capacitor has 50% charge. So we're looking for something in here. What is the time when it's at 50%? Okay, and in this case, 50% is X value. So let's go back to our graph here, and I can go to second calc, and I'm going to go to value and put X at 50. And it's going to tell me what the Y value is. The Y value is 0.069, so I'm going to say 0.0, well, I think I have to put 0.069 because 0.07 is not quite 50. So I'm going to put time is 0.069 seconds. It would achieve 50% charge. Okay, so there is our first log question. Let's see if we can try another one. This one's going to take us a little longer because there's a lot more data to enter. Okay, so pause the video here and see if you can try this question on your own, and then we'll do it together. So it's a really long list here. So if we're going to put this in L1, this is L1 continued. Okay, and then this would be L2, and this would be L2 continued. So this data is how much caffeine is left after a certain number of hours. So the data is very random because everybody started with 200 milligrams of caffeine and they just took readings at different times. So you're going to plot that, put that all into your tables, okay, under edit. Okay, and we're supposed to answer some questions here. All right, first question, it says determine the equation of the logarithmic regression. So it tells us it's a log regression, okay, for the data. So I've already entered everything in. So now I'm going to go to stat calc, and what do I want to do? Mine is natural log regression. So I'll go L1, comma L2. And that's what I get. So the equation is going to be, all right, y equals, and my A value is 35.9 plus, B is negative 6.457, so let's go negative 6.47. Negative 6.47 ln x. By the way, I could rewrite this as y equals 35.9 minus 6.47 ln x. Okay, so that's my equation. So, it says determine the time it takes for an average person to metabolize 50% of the caffeine in her bloodstream. Round this answer to the nearest tenth of an hour. Okay, well, We're supposed to put this into a scatter plot first, so let's take a look at our graph. So first I'm going to go zoom 9. So there's all of our data. Oh, I seem to have one that doesn't seem to fit here. I should quickly go and check to make sure that all of my data is correct. Okay, so I'm going to scroll here and let's make sure that this data is all correct. Is there anything there that doesn't seem to match up? Okay, just looking, because it seemed like there was an X value that didn't seem to look too good there. Seven. An X value of 7. It's not supposed to be 7. It's supposed to be 71. So there. Now let's go look at it. That looks a little bit better. So that's something you can do. You can check, make sure your data. Now on a test, I'm not going to give you that much data. I don't want it to be an error in typing something in. Okay. But let's now figure out the regression equation. Oh, we already did that. Let's paste it. So y equals, let's clear that. So let's go vars 5. Oh, did I not? Did I not calculate that already? Yeah, I did. Oh, that's right, I had to redo it. Okay. So I got to change this. Let's go back to our... This is no longer good because I had to change some data there. So I'm going to have y equals... Let me just put my charger on. Okay, sorry about that. Hopefully you noticed that there was a mistake when you were looking at your data. So y equals 44.39 minus, because it's plus takeaway, and then it should be 8.36 lnx. Okay, so that's a better equation. Now let's paste it. There it is, and if I graph, I'm going to get a line that looks like it's going through. So let's just draw this here. There's no way I'm going to draw all those points, but it looks something like this. Okay, and I should have a point on this graph. I should figure out what the x-intercept is here. Now I can probably look at the data and kind of try to guess, but I'm going to actually figure it out here. I'm going to go to second calc, and I want to find the 0. So if I move along here, I'll press enter. Now I need to cross the x-axis. It's going to keep going here until I cross the x-axis. And I know that y will be negative when I've crossed. Okay, I'm still going, and it doesn't want to go any farther because it's not in my window. So I'm just going to change my window here. Right now my x max is 196. I'm going to change that to, well, I know it could be over 200, so let's just put it to 220. Okay, so I need to know where it's crossing. So it looks like it's in my window now, so let's try it again. So I want to go 2. Okay, let's go, so let's press enter. And now I need to cross the x-axis, so y should become negative. when I see that y becomes negative, there we go. I've crossed the x-axis, and now I can calculate the zero. The zero, it says, is 202.67. 202.67. Now you may say, how is that possible that nobody started with more than 200 milligrams of caffeine? Well, remember that our regression equation is matching the data as best as possible. It's not going to be perfect. Okay, let's label this. What are my two axes? The x value is caffeine level. In milligrams. And this is time in hours. Okay, so there's A done. Let's do B. Determine the time it takes for an average person to metabolize 50% of the caffeine in his or her bloodstream. Okay, 50%. Well, what does 50% mean? Well, if we started with 200, I think what I want for 50% of 200 is, where is there 100 milligrams? Okay, so let's go here. We'll go to calc, and we're going to put the y value, or sorry, the x value as 100. I want to know when there's 100 milligrams, and it tells us it takes 5.9 hours. Okay, so at 5.9 hours, there is 100 milligrams left. And we'll put in brackets, that's 50%. Okay. Now don't forget, that's not everybody, that's average. Determine, okay, it said average person. With all this data, those are all different people. Okay, so now we're going to take a look at a specific person, and we're going to use this data to sort of estimate. So Paula drank a cup of coffee that contained 200 milligrams of caffeine at 10 a.m. How much caffeine will be left in her bloodstream at 9 p.m. in that evening? So first of all, we need to figure out how many hours that's been. Okay, so from 10 a.m. to 9 p.m. how many hours is that? Well, that's 11 hours. So we want to know how much caffeine is left after 11 hours. Okay, so that's going to be, let's say this is 11 hours. We want to find out what is this value. Okay, and the easiest way to do that, I think, for us is to go to y equals, and let's put in another line at y equals 11. Okay, so if I graph, this is 11 hours, I can see that I would want to know what that value is there. So let's go to second calc, and I'm going to go to intersect, and yes, I want the first line, yes, I want the second line. I'm not going to guess. It tells me that when y is 11, there is 54 milligrams of caffeine left. Okay, so let's write that. At 11 hours, there is 50, was it 54? Yeah, 54 milligrams of caffeine left. All right, so there's the kind of question you might get with logs. Again, you don't need to worry too much about, well, why is this a logarithmic equation? Why can't I switch L1 and L2 and then make it an exponential equation? Not to worry, you're just using the calculator to try to figure out what's going on with these scenarios. Okay, so we've got some homework for you to do here, and we'll take the rest up in class.